welcome to InfoStream YouTube channel. In this video, let's discuss how to solve the KCL, that is the Kirchhoff current law problems. You can call them as the nodal analysis. So here we are given with the problem and they have said this is V1, that is voltage across this junction, and this is V2, this is the voltage across this node or the junction, and here all these junctions are connected to ground. So we know that ground voltage will be equal to 0. So for this circuit we must find the value of V1 and V2. So now let's discuss what is KCL. KCL means Kirchhoff current law. So what it tells, summation of the current entering node. The summation of the current entering a node will be equal to summation of the current outgoing from the node. That is, how much amount of the current will enter a node, that much number of current will move outside from the node. So like that. So what is a node? Node means here, where more than two lines will meet, more than two. Here 1, 2, 3, 3 lines are meeting, you can call it as a node. 1, 2, 3, 3 lines are meeting, you can call it as a node. So how much number of current is entering a node, that much number of current will go out from that node. So you can conclude that. So if you add both the entering and outgoing node, it will be equal to 0. So now let's solve this problem. So here if you see, there is a current source. Here also there is a current source. We must find the voltage V1 and V2. So now what I will be doing, current will be moving from positive to negative. So here in this direction if it moves, I will call it as current I1. Current I1. So when it approaches here, the current I1 will be splitted into two parts. Some amount will go to this 4 ohm resistance and some amount of current will move to this 2 ohm resistance. So let's call them as, so this current I will call it as I2, that is current I2, and the current coming towards the 2 ohm resistance I will call it as I3. Now 8 ampere current is there which is moving in this direction. So let us call it as I4. That is current I4. Now when it approaches here, it will be splitted into two parts. So one will go to 4 ohm resistance and another is 8 ohm resistance. But here I2 is coming from V1, that is from voltage source V1, it is coming towards the V2. So you can conclude that I2 will come from this side, I4 will come from this side, and both will merge and move into the 8 ohm resistance. So I will call that current as I5. So now we named all the currents. So now we will check who is entering a node and who is outgoing from a node. So first, voltage V1, voltage source is here. So I will call this as loop number 1. And here another current source is there. So I will call it as second loop. So first loop if you find the value you will get V1. In second loop you will get V2 value. Now let's apply the KCL. Kirchhoff current law to loop number 1. So if you apply the Kirchhoff current law to loop number 1, so when a current is entering a node, we will call it as negative, and when a current is outgoing from a node, we will take it as positive. When a current is entering a node, it will be taken as negative, and when current is outgoing from a node, you will consider it as positive. Now if you see here, for the first loop we are applying, current I1 is entering the node here. Here is the node across which we want to find the voltage. So current I1 is entering the node. Entering means minus. So minus I1. Next, I2. What is I2 doing? I2 is going out from the node. It is moving out. So moving outgoing means positive. Plus I2. Next, I3 is coming out from that node. See here, current I1 came and it splitted into two parts, I2 and I3, which are moving outside from the nodes. So plus I3 will be equal to 0, because when you are taking the entering current as negative and outgoing current as positive, if you add the entering and outgoing current, it will be equal to 0 itself, because same amount of current will enter and same amount of current will outgo now. So the whole will be cancelled out and it will be equal to 0. So we took it as 0. Now we know the value of I1, that is 4 ampere. So I will substitute it here, 4 minus 4 plus, we don't know the value of current I2. So what I will be doing, I will be using the Ohm's law. So what Ohm's law states? V is equal to IR. But I need for the current I. So I will be equal to V divided by R. So you must convert the current I2 in the format of V by R. Where current I2 is there, current I2 is flowing from V1 towards V2. Here, when current I1 came, it split into two, I2 and I3. I2 is flowing from V1 towards V2. So V1 minus V2 divided by, what is the resistance in which the current I2 is flowing? 4 ohm resistance. So divide it by 4 plus I3. So I3 is moving from V1, voltage V1 towards ground G. So whose voltage is equal to 0. V1 minus 0 divided by, through which resistance it is moving? 2 ohm resistance. So divide it by 2. So which will be equal to 0. Now let's simplify and send the constant towards the right hand side. Minus 4 ohm, minus 4, if it go to the right side, it will be equal to plus 4. So if I separate this one, V1 divided by 4 minus V2 divided by 4 plus V1 divided by 2. 0 divided by 2 will be equal to 0 itself. So when I send minus 4 to that side, it will be equal to plus 4. So now V1, V1. So let's combine it. V1 I will take it outside. 1 by 4 plus 1 by 2 minus V2 by 4 will be equal to 4. So let me call this as equation number 1. So again we must create the equation for V2 and let's find the value of V1 and V2 respectively. Now let's apply the KCL, that is Kirchhoff current law, for the loop number 2. So loop number 2 is used for the V2 voltage. So now if you see here, current I4 is entering. It is the current source which has been given. I4 is entering the node. So entering means minus I4. Next, here I2 is coming towards this node. That is, it is also entering the node at that junction or node. So you can write that minus I2. Next, I5. I2 is coming, I4 is coming. Combinedly, it is moving towards the 8 ohm resistance. That is I5. It is moving out from that node. So plus I5 will be equal to 0. Now we know the value of I4. That is 8 ampere. Minus 8 minus I2. So I2 is flowing from V1 towards V2. V1 minus V2 divided by, what is the resistance in between that? That is 4 ohm resistance. So divide it by 4 plus I5. So I5 is flowing from V2 towards the ground. So V2 minus ground voltage will be equal to 0. So divide it by the resistance which is between V2 and ground. That is 8 ohm resistance will be equal to 0. So now let's simplify and send this minus 8 to the right hand side so that it will be equal to plus 8. So minus V1 by 4 minus into minus plus V2 by 4 plus V2 divided by 8 will be equal to minus 8. If you send towards the right hand side, it will be equal to plus 8. So now V2 is here, V2 is here. So let's combine. Minus V1 by 4 plus V2, I will take it outside. 1 by 4 plus 1 by 8 will be equal to 8. So I will call this as equation number 2. So now to find the value of V1 and V2, which are the variables in the formed equations, so we will be using the matrix format. So matrix format means first let's write the numbers. So beside V1, what is there? 1 by 4 plus 1 by 2. So you can simplify and write, or you can write it directly like this. 1 by 4 plus 1 by 2. Next, with V2, what is there? Minus 1 by 4. So V2, if you remove minus 1 by 4 here. Minus 1 by 4. Next here 1 by 4 plus 1 by 8. 1 by 4 plus 1 by 8. Next here, what are the variables used? V1 and V2 are the variables used. So V1, V2, which will be equal to, what are the constants? So constant are 4 and 8, which are at the right hand side. So 4 and 8. Now using this matrix, so let's solve the problem and get the V1 and V2 value. So how to find the V1 and V2 value using the matrix format means we will be using the Cramer's rule. We will be using the Cramer's rule, or you can just use the calculators to solve the problem. So how to use the Cramer's rule means, if I want the value of V1, so V1 will be equal to delta 1 divided by delta. Next, if I want the value of the V2, so V2 will be equal to delta 2 divided by delta. Here, first let's discuss what is delta. Delta means same matrix that you constructed here. That is, delta will be equal to 1 by 4 plus 1 by 2 minus 1 by 4 minus 1 by 4, 1 by 4 plus 1 by 8. So now how to solve this problem means, so just cross multiply this minus these two multiplication minus these two multiplication. So you will get a value here. So you can use the calculator also. Now how to find the delta 1? So delta 1 means what you will be doing, for V1 you are finding, no? So in the place of V1, these are the values with the V1, no? So you will just replace the constant values. That is 4 and 8 will come here in the V1's places and others will be same. Minus 1 by 4, 1 by 4 plus 1 by 8. How to find the delta 2 value? So delta 2 value means you will replace in the place of V2. So constant will be in the place of V2. So I will write here. So 1 by 4 plus 1 by 2 will remain as it is, minus 1 by 4. Here the constant will come at the V2 places for delta 2. So now you can see here we have calculated using the calculator by cross multiplication. So delta value is 0.218, delta 1 is 3.5, delta 2 is 7. So V1 if you want, delta 1 by delta. Delta 1 value is 3.5 and delta value is 0.218. If you divide, you will get 16.05 volts. Next, V2. So V2 means delta 2 value is 7 divided by delta value is 0.218. If you divide, you will get it as 32.11. So the decimal variation is allowed in the problem. So if it is 32.20, 32.33, anything, nothing will happen. So decimal variation is allowed. So hope you understood the topic, how to solve the nodal analysis or the KCL problem. If you have any doubt regarding this topic, please do comment below. I will clarify it. And if you liked the video, please subscribe and support us. Thank you.